Hey, it's Miss Murphy. Welcome back. Today we're going to be talking about all things metric. All right, so the International System of Units, La System Internationale, the SI system, is the metric system, okay? And it is utilized in science because it's so easy to deal with. It is based off of a factor of 10. And every time you move the decimal, you're changing a number by a factor of 10, right? Either times 10 or divided by 10 divided by 10. So it makes it a really easy system to convert between one unit and another, okay? So you need to understand what we mean by units and how to convert them. But we're first going to just take a closer look at the metric system. The base units of the metric system is what I'm going to go over. And then we'll look at how the metric system is organized and with metric prefixes, okay? And how they relate to each other. So I'm going to go to my little whiteboard here, okay? I hope you guys are doing well. And let's continue. I'm distracting myself sometimes. All right, so let's get ourselves straight here. The first thing I'm gonna mention, guys, you're gonna write it down, is base units, okay? And no big deal, I see that, I'll fix it. Base units, no big deal, it's just so that you understand what the symbols mean, okay? If we are measuring the length of something or a distance, you guys know most of this, right? You should. We would, sorry, I'm so sorry, people. Please let me get it together. Okay. We would measure that in meters or kilometers or centimeters or millimeters, depending on how big or small the object is. But the base unit here is meters. So this definition of base unit just simply means the unit. This is our unit, and this is its symbol. And the definition of base just means it for right now. It's I'll give you an example of where we have a different definition, but it is the unit without the prefix. Okay, so anything with an M is going to be a distance, right? We get millimeters, centimeters, kilometers, but this does not have a prefix. So it's our length, distance, base unit. If we were measuring time, our unit is going to be in seconds, right? And it is abbreviated with just a small s. If we are measuring the volume, how much space an object takes up, our units are going to be within the liter category. That's a capital L. If we are measuring the mass, which is how much matter is present, that might be a little bit misleading. We would use grams, right? Small g. If we are doing the amount of matter, right? Moles. So you would think if this is, hold on, that's abbreviated moles. I'm sorry. And it's abbreviated MOL. Okay. This is how many pieces of the substance we have. This is how much those pieces weigh. If you're like, what? Because this might be new to you. The mole, we will use it all the time. This is how many pieces we have. This is how much those pieces weigh. Okay. We'll talk a lot about the mole. I might forget some here. If I do, I apologize. We could measure the frequency, how often something occurs, okay? And that would be the hertz, okay? And there are several ways to symbolize hertz. One is, so give yourself some room here, write small. One is Hz for hertz. But if you think about what the word frequency means, you know, how frequent, how often does something occur? Well, you think about that in a per time sort of way. So hertz means per second, right? It's a way to write per second. Another way to write per second is to write S negative, and that means per second. So if I have a frequency that is 5 hertz, that means it is occurring 5 times every second, per second. Okay, so I could do frequency is measured in hertz. That is, I could write hertz like this, I could write hertz like this, or I could write hertz like this, and I need to know that they all reflect frequency, how often something is occurring. Let's see, can I think of anything else that you need here? Not really. I mean, there's plenty more, but these are going to be our basic measurements. Okay. We got mass, yeah. All right, guys. The other thing, so those are our base units, all right? And so the metric system is a series within the meters or seconds or liters. So when we start talking about the metric system, I'm just going to try to keep this simple, hopefully. What did Miss Murphy just write? I wrote metric up here. So I'm going to try to keep it simple. I never organized it right this. But you might see like milliliter. Oops, we're dealing with meters. So I'm trying to be consistent. Maybe I have millimeters. Maybe I have centimeters, right? Maybe I have decimeters, kilometers, right? I could continue on, hectometers, or maybe I just have a meter. Maybe I just have a meter, all right? Same with seconds, right? I could have milliseconds. I could have seconds. I could have kiloseconds, right? The same with my liter, right? So this is our system. It's a system. And all of these prefixes, the milli, the centi, the deci, the kilo, etc., they all relate to each other by a factor of tens. That is by a placement of the decimal. All right? I can have milliliters, liters, kiloliters, centiliters. They all differ in terms of where that decimal is, right? And, you know, you can have millimoles, guys, AP, you'll see those. Gifted, you might, right? So I could have a millihertz. I could have a megahertz, right? You've heard of megabytes, gigabytes. That's all this is. Okay, so last things, how do these prefixes relate to each other? You may be asking, but oh, that's so cool. How do they relate to each other? You keep saying it's a factor of 10. All right, well, ours are going to range from giga, okay? If I have a lot, a gigabyte, right? It will below that prefix, the next smaller one. There are more up here, guys, but we will never see them. But we will deal with gigas. We will deal with megas. The next smaller one under a mega is a kilo. And then we have a hecto, hecta, actually. We have a deca, all right? And at this, we have our base. And remember when we started this, guys should be writing this down. We said base, and Miss Murphy said there's kind of different ways to talk about base, which reminds me I need to say something. But for us right now, base means no prefix. right? There is no giga, mega, kilo, hecta, deca. It's just a meter. It's just a liter. It's just a second. It's just a mole. It's just any of those things. It's just a hertz, right? It doesn't have a prefix. When is that not the definition, right? It's just a meter, liter, second, mole, hertz. When you're talking about mass, so if you look back on your base unit notes we just took, and we said that the base unit, right? I had base units. You look back, and I had mass, and I had grams, right? That I called that the base unit because there's no prefix. But I've had students do their own research. They said, Miss Murphy, you're wrong. I saw online that the base unit for mass is kilograms. And I said, well, good for you for doing some research. Good for you for telling me I'm wrong. There's two different ways of looking at this. Our base units that you wrote down, I had mentioned, is being defined by having no prefix, all right? The base unit, if you looked it up online for mass, will tell you is the kilogram. That's because we will use constants, numbers used in science in solving math problems, constants, and whenever they incorporate a mass, it's in the kilogram version. It's kind of a weird way to put that. So you could say that technically the base unit is the kilogram, but we're defining base units as not having a prefix. Okay, back to this. These are our prefixes. If we are measuring, if we have very large amounts, we will be using these prefixes. Right? If I have a giga, that is a lot. If I have a mega, that is a lot. After that base, we start getting to really small things that says large amounts. So I now see I see my base goes to deci. It goes to centi. It goes to milli. You've heard of those, all right? After milli comes micro, nano, and pico. I believe under that is femto. It keeps going and going and going. This is super small particles or masses or links. All right, super small amounts, frequencies, times, super small volumes, super small distances. You're talking about the distance between atoms. That's way down here even, right? We'll see frequencies in the nanohertz, okay? All right, now, if my base is 1, my deci is a tenth of that. That is 10 to the negative 1. My centi is a 100th of that. That's 10 to the negative 2. And my milli, I'm going to say it differently this time, right? Decis are smaller than my base unit. So a decimeter is smaller than a meter. If I have a meter, then I have 10 decimeters because a decimeter is a tenth of a meter. I need 10 of these to get one of these. A centimeter is a 100th of a meter. So I need 100 of these to get one of these. Guess what a millimeter is? It is a 1,000th of 1 meter, or 10 to the negative third. 1 times 10 to the negative third, right? Of a meter. Okay? So when I go from the base to the deci, right, if I'm moving, I'm teaching this a little bit different this time. I'm going to have to move these, okay? Okay? So to go from here to here, I times by 10. But to go from here to here, I would divide by 10. I wonder if I threw you there. Let's continue adding that. I'm going to get a different color. You may want to as well. Okay. So actually, let's go like this. I'm going to get rid of these. No, I'm not. No, I'm not. I'm going to come back to that times 10. 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, right? I'll leave space here. Well, micro, you're probably like, oh, I already got this, so I'm going to turn it off. Don't do that. Micro is not 10 to the negative 4. Micro, they're going to stop changing by increments of 1, and it's going to begin and continue to change in increments of 3, so that we are now at negative 6. We are now at negative 9. We are now at negative 12. Okay? Yes. Yes. Now, that is where we go from 1 to smaller. We will now do the same, but we will go from 1 to bigger. Just as with the first 3, we had increments of 1. With the first 3, we will have increments of 1. If a base, let's see, a deca is 10 times bigger than a base. A hecta is 100 times bigger than the base, and a kilo is 1,000 times bigger than the base. That means a deca is 10 to the 1 times bigger, a hecta is 10 to the 2 times bigger, and a kilo is 10 to the 3 times bigger. All right? Now, remember down here, it went in increments of 1 for the first 3 decicentimilli. It went to 1 to 2 to 3. Now, you could call this 10 to the 0 if you want to, guys. 3, 2, 1, 0, negative 1, negative 2, negative 3. And then it went into increments of 3. Or we're going to do the same thing here. So when we get to mega, it's not going to be 10 to the 4th. It's going to be 10 to the 6th. And that is 1, 0, 0, 0, 0, 0, 0. And when we get to giga, it's going to be 10, as hopefully you could guess, to the 9th. All right, let me rewrite that for you guys. 10 to the 9th. And then here we have 10 to the 6th for mega. And that's going to be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. What does that mean, guys? And we're about to be finished here. Then you're going to have to go to the next lesson, take a break. In order to go from the base to anything smaller, right? In order to go from here to here, I times it by 10. Is this 10 times, think times bigger divided smaller, okay? So the deci is 10 times bigger than a centi. So if I have 1 deci, I have 10 centis. It's a form of measurement. Are we measuring in feet? Or are we measuring in inches? If I measure in decimeters, well then for every 1 decimeter, I will have 10 centimeters if I was to measure in centimeters. It's a different unit of measurement. Well, 1 centimeter is equivalent to 10 millimeters, and 1 millimeter is equivalent to, oh, remember that jump? 1,000 micrometers. So if I have a millimeter, I have 1,000 micrometers. A micrometer is 1,000 times bigger than a nanometer. And a nanometer is 1,000 times bigger than a picometer. This is super small. Think of a ruler. No, yeah, no. Let's keep going up. Now, remember all these are going down. This is 10 times bigger than this. So if I have 1 of these, I have 10 of these. If I have one of these, pay attention. If I have one of these, I have 10 times 10, 100 of these. If I have one of these, I have 10 times 10 times 10, I have 1,000 of these. You've got to get this, all of you. Okay, well, this is bigger than this. There's a difference of 3 zeros here. That's 3 tenths. So 1 gigabyte is equivalent to 1,000 megabytes. That's a lot, right? You would much rather have gigabytes than megabytes. Every 1 gigabyte is 1,000 megabytes. 1,000 megabytes is 1,000 times bigger than a kilobyte, right? So you'd much rather have megabytes than kilobytes because it's 1,000 times bigger. A kilobyte, and look at our exponents, it goes from 3 to 2, so it's only 10 times bigger here, 10 times bigger here, and 10 times bigger here. Okay? A lot of numbers, but it's just decimals moving. Over here, and then I'm going to finish it, is in order to go from a pico to a nano, right? Well, nanos are bigger. So if I saw that I was turning a pico into a nano, I would have to make it smaller, right? So I will be dividing by 1,000 to go from here to here. To go from here to here, I would divide by 1,000. To go from here to here, I would divide by 1,000. And now I'm in the 3 to 2, so I would divide by 100. That's 10. It's not a 100. 3 to 2, 10. I would divide by 10, and I would divide by 10. Okay? If I'm at the base, the meter or liter or gram or whatever, and I need a deca, meter or liter or gram, going from here to here, I would divide by 10. If I'm going from the deca to the hecta, I would divide by 10. If I'm going from a kilo, the hecta to a kilo, I would divide by 10. If I'm going from the kilo to the mega, I would divide by 10. And if I'm going from the mega to the giga, I would divide by 10. All right, I know it got a little bit messy. I should have planned it a little bit better. Another thing you might need to realize before we say bye, and you guys might have some questions, start Remind 101ing me. Talk to your friends, ask them for some help first. You're gonna have to go watch the next video to actually apply this. Boy, I'm gonna have to write this down on a piece of paper so I can refer back to it all the time. I'm gonna have to go do that so I can show it to you in your notes and show you how to use it. Okay, have it down, go make it neat on its own piece of paper, please. Thank you. Go make this neat on its own piece of paper. I'll make my own. Maybe I'll take a picture of it and attach it, send it to you as a material resource. Just one thing I want you to realize though, is that 10 times 10 times 10 is equal to 1 with 3 zeros after it, okay? 100 or 1,000 times 1,000, you may know this, some of us don't though, is equal to 1 with 1, 2, 3, 4, 5, 6 zeros after it, all right? Need you to be aware of that. If you were to divide, you would take the zeros away. Okay. I think that was good for now. Once again, please be mindful that this is just understanding. It's not applying, but if you understand this, it's so easy to apply it. All right. But converting units, which will be the next lesson, is like a given. You have to do it all the time, all the time. If you're dealing with math problems, and parts of chemistry is all math. Parts is not, but some parts is all math. So you need to figure this out and figure out what your questions are and make sure that you have those put together so that you can bring your questions to me and then I can help you. Okay, I can really help you. All right. Till then, see you later. Don't forget you need to be moving on to that metric conversion video. I'll try to keep it short and sweet. All right, let me go here and press end. Bye. See ya.